Good morning, sir.
Very good morning, student. Ma, what did we discuss in the last class? Children, tell me what did we discuss. Ma.
Enthalpy of fusion.
Enthalpy of
Fusion.
fusion. Completed na enthalpy of fusion. Right. Okay. Right. Right. Let us start. Banu, tell me what is enthalpy of fusion? Banu.
The enthalpy of change that accompanies melting of 1 mole of a solid substance at standard condition.
Right. Enthalpy of fusion is completed. Now, enthalpy of vaporization. Then what is enthalpy of vaporization? Let me continue. So listen carefully. All enthalpies to be completed by this class. Later we will enter to the Hess law of constant heat summation if possible. Now, enthalpy of fusion. Enthalpy of fusion means, children, the amount of heat fusion completed, na? Right. Enthalpy of vaporization. Enthalpy of vaporization means the amount of heat is required to converts the 1 mole of liquid as its vapor state is called as enthalpy of vaporization. Right. Okay now.
Okay, sir.
Okay. Right. Enthalpy of vaporization. Vaporization means to be converted as its vapor. That it is called as enthalpy of vaporization. Okay. Vaporization. The heat change is also say like this, children. But enthalpy of vaporization denoted as delta H vapor. Okay. This process is an endothermic process. Endothermic process. Endothermic process. Endothermic process means, children, tell me, delta H is negative or positive sign? Delta H.
Positive.
Definition. I am framing the definition for enthalpy of vaporization. Right, children. The amount of heat is required. The amount of heat is required to convert 1 mole of liquid substance
To vapor substance.
yes, liquid substance as its vapor phase or vapor state. Vapor state. This is called as enthalpy of vaporization. So the amount of heat is required to convert 1 mole of liquid substance as its vapor state. That it is called as enthalpy of vaporization. For the example, children, what I am taking water, H2O. H2O is in liquid state. Okay. To convert as its vapor state, H2O is in a vapor state or gaseous state. Gaseous is nothing but vapor. Clear, na children? Okay, now this is gas phase like this. For this process, delta H vaporization is plus 40.79 kilojoules molecules. This is plus. Plus means endothermic process. Children, clear na? It's clear.
Clear, sir.
Now, I am giving one more definition related with enthalpy of vaporization.
Sir, one doubt, sir. Sir, it is plus 40.6 kilojoule, no, sir.
This is 40.40, 40.79 kilojoule mole inverse. Tell me, what is your doubt?
Plus 40.6 kilojoule, no, sir.
Plus 40.6 or 79, no problem. 40.79. Now, this value is always constant values. These are okay, na? Now, question lo ఏమంటాడంటే, my question like this NCERT example, the enthalpy of vaporization of my question, enthalpy of vaporization of water means molar enthalpy of vaporization. Why? Because one mole consider cheste molar enthalpy is reminder. Molar enthalpy of vaporization simple of water is 40.79 kilojoules. Okay, find how much heat is required to converts 9 grams of water as its vapor at standard conditions. Can you solve this problem, children?
$20.39 plus 20.39.
20.195. 20.195. It's clear? Clear now? That given data is giving this information. Molar enthalpy means my answer is molar enthalpy of vaporization of H2O is 40.79 kilojoules. That it is energy or heat. How much energy and how much heat is required? How much? So find how much energy. This is energy is here. How much energy? How much energy is required to convert 9 grams of water as its as its vapor state, as its vapor as standard conditions, that it is mean children. So to convert 18 grams of H2O liquid as H2O gas is 40.79 kilojoule. The question is asking about the 9 grams. So 9 grams is how much? Cross multiplication. 40.79 upon 18 into 9 is equal to 20 point. So this is 3 means 35 means 39.5. 395 kilojoules. It's clear, children?
Clear, sir. Yes, sir.
I'm moving to continuation of this one. Okay. So God. Right. Now I would like to give the another definition for this one. Okay. Latent heat of vaporization is, let me discuss children. What is the latent heat of vaporization? So it's a particular definition for latent heat of vaporization. Let me discuss now. Right? The amount of heat. The amount of heat is required to converts to 1 gram of liquid as its vapor is called as latent heat of vaporization. It's clear. So amount of energy is required to convert the 1 gram of liquid as its vapor. 1 mole of liquid as its enthalpy of vaporization. 1 gram conversion, latent heat of vaporization. It's clear, children. Now, latent heat of vaporization is equal latent heat of vaporization is equal to enthalpy of vaporization
divided by mass.
enthalpy of vaporization upon molecular weight of liquid or substance. Right. This is a latent heat of vaporization. It's going to late. Right? Clear, children, this is clear. Right. Not copied now. Copied.
Yes, sir.
Right. This is the discussion about the latent heat of vaporization and latent heat. This means enthalpy of vaporization. Now, let me discuss now, children. Latent heat of okay, na? Fusion. So, previous case ki discussion related ga untaru. Latent heats both ఒకే దగ్గర related ga ఉండడం కోసం now I am discussing here. Now means latent heat of fusion. Then what is the latent heat of fusion? Let me discuss. Right. Now, latent heat of fusion, children. Tell me what is latent heat of fusion? Similar definition.
The enthalpy changes that accompany melting of 1 gram of a solid substance at standard condition.
Right. As it's a liquid. Simple definition. Very good. The amount of heat is required. The amount of heat is required to the amount of heat is required to converts the 1 gram of solid substance as its liquid. As its liquid is called as latent heat of fusion. Latent heat of fusion. Right. What is the formula? Latent heat of fusion for formula? Tell me, children. Tell me.
Enthalpy of fusion by molecular weight of substance.
Heat of fusion is equal to, okay. Now, enthalpy of fusion. Enthalpy of fusion upon molecular weight.
Sir,
Ma.
sir, every time when someone is oning their mic, sir, your voice is getting low, sir. We can't hear it for 1 minute.
Yes, sir.
Everybody, my voice is not audible.
Audible,
No,
sir.
sir. No, sir. That one.
It's audible.
When you are talking, someone is on the mic. Your voice is not hearing for 1 second or 5 seconds.
Yes, sir.
I think it is network issues, children.
Sir, one member is network issue, sir. For all members is what the problem, sir.
When I'm talking with a particular person, the other members are okay, no, that it is.
Few seconds back also it got like like
No,
this
sir.
only.
ఎవరు మైక్ ఆన్ చేసినా ఒక 1 minute పాటు అంటే ఒక 30 seconds, 40 seconds పాటు వాయిస్ వినిపించట్లేదు సార్.
I don't know, children, but then what is the problem? Now, okay?
Yes, sir.
Sir, 40 seconds atla kaadu, sir. Only 3 seconds, 5 seconds.
Okay, I will check in the next. When I free, I will check the with blank teaching. I will check that, children. Okay. Thank you. Now let me discuss about this one. Now my question, children. NCERT example. My question. Among water and acetone, which has greater latent heat of vaporization. Latent heat of vaporization. Okay. Explain. Can anybody in the class? Children? Anybody in the class?
Acetone, sir.
Acetone. Why, Amina? Why it is? Why do you think so?
It has a greater latent heat of vaporization, sir.
Okay. Next, Vashit, Roser, Basabi.
Normal boiling point of acetone is less than that of water.
That's right. Okay. Right, children. Let me discuss now. My answer for this one is so among water and acetone, which has the greater latent heat of vaporization, answer is water.
Sir, can I say?
Water. Reason. So in water, H2O molecules are bonded with or attracted with, bonded with ion Hb, intermolecular hydrogen bond. Hydrogen bond. Okay. Whereas in acetone, there is a dipole. Okay. Dipole attraction forces which are weaker than hydrogen bond, so that acetone with low heat and vaporization. Now, right. Now, key point. Latent heat of vaporization. Latent heat of vaporization depends on intermolecular forces. Intermolecular forces. Okay. Latent heat of vaporization is directly proportional to intermolecular forces. Children, it's clear? Children, it's clear.
Clear, sir.
Now, latent heat of vaporization, latent heat of fusion, okay, na? Enthalpy of fusion, enthalpy of vaporization completed. Now, let me continue with okay, enthalpy of sublimation. Enthalpy of sublimation. Children, what do you think so?
Means
About this?
change in heat enthalpy when 1 mole of a solid is directly converted into gaseous
Yes,
state.
yes, very good.
Temperature below its melting.
Right, very good. It's correct. Very good answer. The amount of heat, the heat change, change when 1 mole of, already I told you children, these all are considered as molar enthalpies. Why? Because it is considered to 1 mole of the heat change when 1 mole of solid substance directly changed to its gaseous state. gaseous state. It's clear, which is called as enthalpy of sublimation, children. For the example, I am taking, children. This is for the example. This is a dry ice, solid CO2, which is called as a dry ice, to be converted as a gaseous carbon dioxide. For this process, due to weak intermolecular forces, its value is very low. Okay, delta H for this process is just 25.2 kilojoule. Okay, molecules at 195 K. Why? Because in this temperature, it is in a solid state. After room temperature, CO2 is gaseous state. That's why it is cannot be expressed in terms of standard conditions. It could explain chilling. Next, naphthalene C10H8, which is in solid state, to be converted as a C10H8 in a gaseous state. For this process, delta H is equal to 73 kilojoule molecules. Children, it's clear?
Yes, sir.
Yes, sir.
What I'm telling to children. So enthalpy of sublimation is sum of enthalpy of fusion and vaporization. Simple. Enthalpy of sublimation, delta H sublimation is equal to delta H fusion plus delta H vaporization. Clear now? Summation of these two is equals to, okay now. So solid to liquid, liquid to vaporization. This renditi summation just sublimation equal out. It's clear. Regarding this one, anybody doubt, children?
No, sir.
Sir, is this endodermic or exothermic? Sir?
Endothermic process. Endothermic process. Why? Because phase transformation is going there. Right. Now
Sir, no.
I am going to the
Sir. Now also it happened 1 second, not hearing, sir.
Yes, sir.
conversion.
Sir, we did not hear you, sir. Can you explain it again, sir? Endothermic or exothermic?
So when heat is absorbed in that situation, heat is absorbed in which the situation that it is always endothermic. Heat is evolved situation is called as, for the example, vaporization, heat required, endothermic. Condensation, heat is evolved. The gaseous solid to liquid, endothermic, liquid to gas, endothermic. Gas to liquid, exothermic, liquid to solid, endothermic. Clear now? Clear?
Yes, sir. Clear, sir.
Yes, sir.
Yes. So for the understanding of this one, children, I am giving the enthalpies for the example for understanding of this one. Just a little bit graph what I am taking, children. Say graph taking what I am taking graph for the example. For the example, just observe, children, this one. Just observe this one. Now, this is a potential energy. Potential energy means enthalpy. Enthalpy. Potential energy at constant pressure is called as enthalpy. Constant volume is internal energy. Right? So, this is the state which indicating the ice. This is the state which indicating the water. This is the state which indicating the water vapor. Water vapor. So this is the energy along this one, energy. Energy increasing. Right, children? Which has the lowest energy? Which has lowest energy? This is solids. Solids have a lowest energy than that of liquid, than that of gas. Conversion of gas to solid to liquid, liquid to gas. It means it heat absorb చేసేసుకోవాలా higher energy రావాలంటే. This process is endothermic. Conversion of gas to liquid, energy emit అవుతుంది, decrease అవుతుంది కాబట్టి. This is exo. Conversion of this one to this one is exothermic. Understand now?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Now, another enthalpy term, that it is enthalpy of solution. Enthalpy of solution. Then what is the meaning of enthalpy of solution, children? For the example, what I am taking, this is a vessel containing a not fixed quantity. Here two different definitions are there. Integral enthalpy of solution and enthalpy of solution. Integral manaki definition ledu. No need to discussion of the internal. Internal ki enthalpy ki just I will explain this one. Right. Now, this is a solvent. What I am taking here, this is a solvent, not a fixed quantity, infinite quantity of solvent. Infinite quantity of solvent. Okay. Now, this is the 1 mole of solute. Solute, this is 1 mole. 1 mole of solute. Solute. When it is added to this one, and dissolved, due to this dissolving process, based on the nature of solvent and solute, heat may be evolved or heat may be absorbed. Such heat change is called as enthalpy of solution. It's clear, the children? It's clear.
Yes,
Okay.
sir.
Right. The heat change. The heat change during the heat change during dissolving of 1 mole of solute in a infinite volume of solvent is called as enthalpy of solution. Enthalpy of solution. It's clear. This is the delta H here. Okay, solution. So it may be either negative or positive. It may be exo or endothermic process. Why? Because it is depends upon the nature of solvent and solute. It's clear. Let me discuss about the 1 mole. Integral means a fixed volume తీసుకుంటే integral enthalpy of solution. That it is not included in our syllabus. That's why I am not discussing. Right, children? For the example, what I am taking here, that it is first sulfuric acid. Example 1, H2SO4 plus infinite volume of water. This is in liquid state. Aqueous solution, AQ, water means gives rise sulfuric acid, H2SO4, aqueous solution. For this process, delta H solution is minus, means exothermic, 20.2 kilojoule. per mole. Sorry, kilocalories. Kilocalories. So it is an exothermic process, this process. Now, example 2 I am going. Potassium chloride when treated with means dissolved in water gives rise. This is a solid, this is water. So to producing the aqueous KCl solution. So for this process, delta H is a positive, means endothermic, that it is 4.4 kilocalories. Another example what I am taking, children. This is potassium hydroxide and sodium hydroxide is dissolved in water. Sodium carbonate is also to forming the aqueous solution of KOH. Aqueous solution for this process is minus, sorry, this is delta H is equal to minus 13.3 kilocalories. Now note point. Note. Later you will know about this point. Formation of ideal solution. Formation of ideal solution. Ideal solution. Change in enthalpy or enthalpy change. Change in enthalpy. Change in enthalpy is 0. Reminder. Change in enthalpy is 0. It's clear. Okay. Right? Change in enthalpy is 0. Change in enthalpy is 0. It's clear, children. Right. Clear now? It's clear now?
Yes, sir. Yes, sir.
Right. Going to the another enthalpy definition, that it is enthalpy of hydration. Enthalpy of hydration. Enthalpy of hydration. Then what is the meaning of enthalpy of hydration? Right, children? So that first I am explaining the example, later we will apply the definition. Means this is a copper sulfate solution. Okay. No water molecule, means anhydrous. Anhydrous state combines with the requisite number of H2O molecules, liquid state, to forming the more stable of its salt. Okay. The amount of heat change is observed is called as enthalpy of hydration. Hydration. This is always exothermic process, children. Reminder, this is always exothermic process. Minus 78.2 kilojoules. So values is not important. Process is important. Problem lo vade istadu values. Man process ni pay chesesukoni that it is endo or exo, we have to find out. Right, children. Now definition for this one. Anvita, can you say the definition for this one? Anvita. Durga.
The amount of heat change during the dissolving of 1 mole of a substance in water.
Combines with the requisite okay, na, amount of water to form its stable salt is called as enthalpy of hydration. Actually, the amount of heat is evolved. Simple. Alright. Evolved. Simple heat change and note just now. The heat change. The heat change or enthalpy change. The heat change during during anhydrous salt combines with requisite number of
Moles of water to convert into water.
very good requisite number of water molecules to form its stable salt is called as enthalpy of hydration. Children, it's clear now? Clear?
Yes, sir.
Right. Next, enthalpies. Another enthalpy, let me discuss children. That is the enthalpy of precipitation. Completed na paano? Enthalpy of precipitation? No. Not yet. Not yet. Now, enthalpy of precipitation. Simple, all enthalpies are related to 1 mole. All definitions are similar definition, children. Very close. A name lone manki information untadi definition ki. Enthalpy of precipitation.
Hydration enthalpy is exothermic, sir.
Yes, it is always exothermic.
Okay.
Enthalpy of precipitation is also always exothermic. Right, children? Now, for the example, what I am taking here, first example, later I will explain. Now, example I am taking, children, like this. This is a barium chloride aqueous solution. Barium chloride aqueous solution when treated with sodium sulfate aqueous solution. Now, these ions, sulfate ion is combined with barium to forming the barium sulfate as PPT. PPT means precipitation, and producing the aqueous NaCl solution. 2 moles of aqueous NaCl. For this reaction, delta H PPT is just 24 minus 24.67 kilojoules. This is also exothermic process, reminder. Okay, na? So simply the amount of heat change or the heat change during the precipitation of 1 mole of during the formation of 1 mole of PPT. Simple. This is called as enthalpy of precipitation. Cheppandi the heat change. Tell me, ma. The heat change during formation of 1 mole of precipitation. 1 mole of precipitation. It's clear, na, children? Children, it's clear.
Yes,
it is called as enthalpy of precipitation. Simple.
Sir,
Ma.
what is the color of BaSO for precipitate, sir?
Huh?
What is the color of BaSO for precipitate, sir?
Okay, na? Which color? Which color?
Yes, blue color only, sir. White color.
White color. White PPT. Already I wrote here. Okay, na?
Okay, sir.
Okay, na? Right. Ah, right, children. Next, let me discuss about the another definition for other enthalpies. Right. Now, enthalpy of transition. This is next one is enthalpy. చూసారమ్మా అన్ని ఎంథాల్పీ చెప్పే కదా ద టర్మ్ ఎంథాల్పీ టోటల్ లెసన్ ఎంథాల్పీ చుట్టే రివాల్వ్ అవుతుంది ఎంథాల్పీ ఆఫ్ ట్రాన్సిషన్ then
Enthalpy
what is the
one mole of substance undergoes transition from one allotropic form to another.
very good so the heat change when or during one allotropic form to another that it is called as a enthalpy of transition the heat change during conversion of one allotropic form to other. Okay, this is called as a enthalpy of transition, children. So the best example, graphite, conversion of graphite to graphite to diamond. Now graphite is the allotropic form of carbon. Graphite, okay, changed to or converted to carbon in the form of diamond. Okay. Now, for these conversions, this is called as enthalpy of transition of course. Delta H is equal to the value is 1.90 kilojoules. Endothermic or exothermic?
Endothermic, sir.
Endothermic. If in case diamond to graphite?
Exothermic.
ఎగ్జోథర్మిక్ ఎప్పుడైనా ఫార్వర్డ్ రియాక్షన్ ఈ డైరెక్షన్ లో ఎండ్ అయితే ఈ డైరెక్షన్ దాని ఆపోజిట్ డైరెక్షన్ ఎగ్జో అవుతుంది ఫర్ ది ఎగ్జాంపుల్ సి డైమండ్ కన్వర్ట్స్ యాజ్ సి గ్రాఫైట్ for this reaction tell me children what is delta H value
minus 1.9
Minus
-1.90 kilojoules. Teja, it's clear, Nara?
Yes, sir.
Banu? Okay, ma, very good. Banu,
sir,
my voice is audible?
audible, sir.
Okay, ma. Now, important for NEET. ఇంకా NEET important. ఇంకొకటి ఉందన్న ఎంథాల్పీ ఆఫ్ డిజల్యూషన్ ఉంది. వన్ కాన్సంట్రేషన్ టు అనదర్ కాన్సంట్రేషన్ దట్ ఈస్ నాట్ పర్ఫెక్ట్ సిగ్నిఫికెంట్ ఏం లేదు దానికి. సార్ చూద్దాం అది కూడా. ఫస్ట్ లెట్ మీ డిస్కస్ అబౌట్ ద బాండ్ ఎంథాల్పీ. ఓకేనా, ఆఫ్టర్ డిస్కషన్ ఆఫ్ బాండ్ ఎంథాల్పీ విచ్ ఇస్ మోస్ట్ ఇంపార్టెంట్ ఫర్ NEET అండ్ ఆల్ అదర్ ఎంట్రీస్ పాయింట్ ఆఫ్ వ్యూ. ఇంకా దాని తర్వాత ఎంథాల్పీ ఆఫ్ డిజల్యూషన్. డిజల్యూషన్ మీన్స్ ఇట్ చేంజెస్ టు వన్ కాన్సంట్రేషన్ టు అనదర్ కాన్సంట్రేషన్. Just one second, children. Right. Next, bond enthalpy or bond dissociation enthalpy. Then what is bond enthalpy or bond dissociation enthalpy? Let me discuss. Bond enthalpy.
The standard enthalpy of a reaction related to bond enthalpies of reactants and products in the gas.
Okay. So another one is also very similar with children, that it is enthalpy of atomization is also one is there. That enthalpy of atomization is almost similar to enthalpy of okay, no? Bond enthalpy. So first, enthalpy of atomization ki related ga undi kabatti first discuss later we will discuss this one. Enthalpy of atomization.
Change in enthalpy on breaking 1 mole of bonds completely to obtain atom in the gas phase.
Enthalpy of atomization. So should be taking the gaseous form of molecule to convert as its constituent ions. Just it is reversible. Reverse means opposite to the enthalpy of formation. Right? Now I'm writing the this is a definition for this one. Right? The heat change or the amount of heat. The heat change to convert a gaseous molecule as its constituent gaseous atoms. That it is called as enthalpy of atomization. For the example, children, what I am taking, this is the hydrogen H2, which is in gaseous state. Okay, some heat supplied to this one, it will be changed to hydrogen gaseous state. It should be in the atomic state. So for this process, delta H, A for atomization, okay, is that it is to break some of the energies required. That's why it is simply it may be negative or positive, but it is not mentioning. But some decomposition of the compounds is in exothermic process is also there. That's why it may be endothermic or exothermic, but the given example is endothermic. 435 kilojoules, okay, na, molecules. I am taking the one more example, children, that it is a CH4 methane, which is in the gaseous state. To convert as its constant gaseous ions, carbon should be in the gaseous and hydrogen is also should be in the gaseous state. How many hydrogen atoms are there? 4. 1 carbon atom. For this process, delta H, okay, na, atomic. It's clear now. Clear now. Right. Right. Clear. This is also very related with bond enthalpy or bond dissociation enthalpy. How to check in this one? Ante each bond ni leda bond average ni express chesta untam bond enthalpy lo. Ikkadaithe total molecule conversion ki. Idaithe total vastundi. Akkadaithe each bond ki explanation iవ్వాలి. That it is the difference between the enthalpy of atomization and bond enthalpy. Right. Now let me discuss about the bond enthalpy, which is important for NEET. Now, bond enthalpy. Bond enthalpy. Already you told that Banusri already told that it is the amount of heat is required to break the 1 mole of bond, which is called as simply which is called as of its gaseous state, is called as a bond enthalpy. Okay, gaseous state lo exist in a molecule lo one type of bond ni break cheyadaniki, 1 mole of bond ni break cheyadaniki how much amount of energy is required, that it is called as bond enthalpy. Means the amount of energy or the heat change, the amount of energy is required to break 1 mole of bonds of gaseous molecules. Is called as a bond enthalpy. Already this is already we discussed in the above example. This is hydrogen bond hydrogen, which is in gaseous state, to be converted as a 2 hydrogen atoms in gaseous state. For this reaction, delta H is equal to plus 435 kilojoule molecules. In case of I am taking chlorine bond chlorine Cl2. Okay, to break this bond, to convert as a 2 chlorine gaseous atoms. For this delta H bond energy Be is just simply we may take this as a 242 kilojoule mole inverse. Now observe children. In case of O double bond O gaseous gives rise to gaseous oxygen atoms. For this delta H bond energy is 4 to 8 kilojoule molecules. Children understand now? Understand now? Right. Now concept. Polyatomic molecule. Then what is polyatomic molecule, children? Do you know? Polyatomic molecule.
The molecule which contains 2 or more atoms.
Atoms.
Which contains
2 or
poly
more.
means many means more than 2. That it is called as polyatomic molecules. It's clear. In case of the molecule which contains contains more than 2 atoms. Is called as polyatomic molecule. Clear? For the example, CH4 polyatomic molecule, ammonia polyatomic. So many examples are CO2 polyatomic molecule, etc. Clear, na children?
Clear, sir.
Clear. So in this situation, in case of methane. Okay. So bond dissociation energy of C bond H breaking of this bond. For example, this is I am giving the numbering for breaking of bond. This is first C bond H. First, this is C bond H2, C bond H3, C bond H4. A reminder, children, all bond energies of this C bond H is not same. Why? Because in case of breaking of this bond, it is already exists with 3 hydrogen atoms with more stable. After removing of this hydrogen, in case of breaking of this one, so it is associates with 2 hydrogen atoms. So chemical atmosphere is changed, so that C bond H1 is not equals to C bond H2 bond energy. In breaking of C bond H of this one, only one hydrogen C bond H bond is there, so that it is also differed. In case of this one, this is also differed, so that all C bond H are different. So in that situation, we have to take the C bond H bond energy average. Roger, understand na, my concept? Roger, ma, tell me, understand na?
Sir, it's confusing, sir.
It is confused. Okay, going to the next one.
Sir, one can say that why they differ, sir.
Okay, I am explaining. One second, I am explaining. Right. For the example, in case of polyatomic molecules, we are consider that all bonds are not in same chemical atmosphere, so that we are taking the bond energies of average. For the example statement, I am giving the statement first. First, I am giving the statement. In case of polyatomic molecules, in case of polyatomic molecules, breaking of a similar covalent bond, similar covalent bond do not exist, means does not exist with similar chemical atmosphere. So that such bonds show different bond energies due to this average bond energy will be expressed. It's clear, children, what will be happening. Let me take the one example for understanding of this one. The best example is CH4. So for understanding of this concept, children, I am taking very clearly. Now, this is a methane. C bond H bond H bond H bond H, which is in gaseous state. 2 breaks 2. This bond will be breaking. C bond H, bond H, bond H, radical gaseous, plus H radical gaseous. Radical means containing the unpaired electron. So for this process, delta H is equal to 427 kilojoule monomers. For 27 kilojoule monomers. 427 kilojoule monomers. Observe children, to breaking of this bond is breaking. Whenever it is breaking, it is already exist 1, 2, 3 bonds. Now breaking of this bond, next C radical bond H, bond H, bond H, which is in gaseous. Useless. In case of breaking up in this situation C bond H, it is a 2 bond pair, 1 unpaired electron. But here breaking situation, 3 bond pairs surrounded it. But breaking of C bond H, 2 bond pairs, 1 unpaired electron. Chemical atmosphere is different. So bond enthalpy is also, why? Because stability is different. Bond energy is also different. For breaking of this one, C bond H, bond H, radical gaseous, plus hydrogen gaseous. For this one, delta H. ఇప్పుడు 1 అనుకుందాం, 1, 2 అనుకోవాలి. సరే, యావరేజ్ తీసుకుందాం సార్. Now, this is a 439 kilojoule monomers. 439 kilojoule monomers. Now, breaking of this one, C bond H, bond H, radical gaseous, to be converted as breaking of this bond. H bond C, 1. Okay. This is already existing the radical, 2 radical. This is with 3 radical, plus hydrogen radical gaseous. For this process, delta H is equal to plus 452 kilojoule monomers. In case of breaking of this bond, H bond C with 3 gaseous gives rise to C gaseous plus, okay, hydrogen gaseous. For this process, delta H is equal to 347 kilojoule monomers. Right, children? For this explanation, what I am going here now, bond average total and different, and all bonds are breaking by participation of C bond H only. Okay, now here participating the C bond H, but breaking of C bond H for first one 427, second one is 439, so third one is 452, fourth one is 437. Different bond energies are there for C bond H. So to remove this ambiguity for expression, which bond we are not confined the breaking, so that we are taking the average bond energy. So ఇక్కడ చూడండి తల్లి, మనం ఎలా కన్సిడర్ చేసుకోవచ్చు చూడండి. this one cancel, this one cancel, this one cancel. Add this equation, means CH4 gaseous gives rise C plus, okay, na, hydrogen, 4 hydrogen atoms gaseous. For this one, all these summations, delta H is equal to 1665 kilojoule. Now, C bond H, delta H, bond energy of C bond H, average bond energy average is total 166 by how many number of bonds break? 4 by 4 is equal to, or equals to, that it is 416. 416.125 kilojoules monomers. In case of ammonia for example, okay. Now bond energies idantha vachesindi anko mari. For example, gives rise N plus 3H. Okay. Delta H is equal to Y kilojoules vachesindi anukunnanu. Y kilojoule mole inverse. Then N bond H, okay, na? Bond energy average is equal to Y by చెప్పండి, how many bonds? 1, 2, 3. Okay, na? Kilo joule mole inverse. Children, understand my concept?
Yes, sir.
Understand?
Yes, sir. Understood.
Children?
Yes, sir.
Now, so different species having the different bond energies values, it is depends upon their stability, chemical atmosphere of the reacting and the formed product. Finally, I am going to the applications of bond energy. Question is frequently asking from this area in NEET. Listen carefully. Applications. Applications of bond enthalpy. Applications of bond enthalpy. Now, let me discuss it. Clear? Right. Now, first one. Determination of enthalpy of reaction. Need a specialist for NEET. Determination of enthalpy of reaction. Enthalpy of reaction. Right. Then what is the enthalpy of reaction? How we will discuss or determine by using the enthalpy of reaction. Right, children? Important for this one. Delta H reaction. Standard condition తీసుకుంటే మీ standard condition తీసేసుకోండి. Normal condition అయినా మీ ఇష్టం. Sigma means summation of bond enthalpies of reactants. Reminder, in every case product minus reactant, here only reactant minus product. Reminder, bond enthalpies of reactants minus sigma bond enthalpies of products. Reminder. Okay, so that important for this one, most important. Clear? So how to solve the problem in NEET levels in the next class. Now that second application. Okay, determination of resonance energy. This is also important. Determination of resonance energy. Next application. Determination of resonance energy. Then how to determine the resonance energy by using this one? Let me discuss. Now resonance energy is equal to resonance energy equals to experimental heat of formation, experimental experimental heat of formation. Heat of formation minus calculated heat of formation. Calculated heat of formation. Right, children? ఇంకా 2 ఉన్నాయి నాన్న మనకి. One is heat of hydrogenation and heat of solution, and finally Barnhaber cycle, means his law of constant heat summation. His law of constant heat summation. ఇంకా ఇది డిస్కషన్ అయిపోతే మనకి ఈ పార్ట్ అంటే ఫస్ట్ లా ఆఫ్ థర్మోడైనమిక్స్ కంప్లీట్ అయిపోతుంది, కెమిస్ట్రీ కూడా కంప్లీట్ అయిపోతుంది. సో ప్రాబ్లమ్స్ సాల్వ్ చేయాలి మనం దానికి. సచ్ డిస్కషన్స్ విల్ బి ఇన్ అవర్ నెక్స్ట్ క్లాస్. Regarding this one, children, anybody doubt? Children, anybody doubt?
No doubt, sir.
No doubt.